Hello everyone and welcome to another lecture of vector algebra. Now today's topic is very important, which is scalar or dot product. In almost all branches related to mathematics, you have this particular topic. Physics, maybe mathematics, maybe engineering mathematics. In all branches you will get this particular topic. Now let us try to understand what is dot or scalar product. So suppose a bar and b bar be two non-zero vector, means they have some magnitude, inclined at an angle theta. So that means if this vector is a bar and this vector is b bar, so angle between them is how much? Theta. This is given, okay? Theta. Then scalar product or dot product of these two vector a bar and b bar is denoted like this. How? A bar dot b bar. Okay, so this is how we'll denote it. And what is the formula? It's modulus a bar, magnitude of b bar, and then cos of angle between a and b. Okay, cos of theta. So modulus a bar, magnitude of a bar is, we can simply write a, magnitude of b bar is b, and then what? Cos theta. Okay, now see here, there is no direction related thing. A, b, all are scalar quantity. So is a scalar quantity. Is a scalar quantity. Okay, so first we have the formula for a bar dot b bar, and then we learn that a bar dot b bar is nothing but a what? Scalar quantity. Now let us see some properties, very important properties related to scalar or dot product. First one is what? Commutative property. Now just now we have shown that what is a bar dot b bar? It is nothing but a b cos theta. Okay, so similarly, if you find b dot a, it will be modulus b bar, means b modulus a bar a, and then cos of theta. So both are same. So that is why a dot b is equals to what? B dot a. Dot product is commutative. Next we have distributive property. So where you can write like this: a dot b bar plus c bar is equals to a dot b plus a dot c. It's very simple. Then b plus a dot c can also be written like this: b dot a and c dot a. So these are called distributive property on addition, vector addition. Then one more important formula, which is projection formula. So projection formula is like this. Suppose a bar on b bar, no? So if this is a vector a bar and this vector is suppose b bar, then projection of a bar on b bar. So we are talking about this part. So how to find this one? A dot b divided by modulus b bar. If it is on b bar, so modulus b bar will be in the denominator. If we write projection of b bar on a bar, then modulus a bar will be in the denominator. Now you see b bar by modulus b bar. This thing, so you know na, b bar vector by its magnitude is what? Unit vector along b bar direction. So you can write like this also: a dot b cap. And then one more interesting thing is, if a bar dot b bar equals to 0, then they are perpendicular. So if two vectors are perpendicular, suppose this is a bar, this is b bar. If two vectors are perpendicular, then what is theta? Theta equals to 90 degree. And in the formula of a dot b is what? A b cos theta, cos 90. Cos 90 is how much? 0. Okay, so that is why if they are perpendicular, a bar and b bar are perpendicular, their dot product will be 0. So we have to use this particular formula in so many occasions. Then comes I dot I. So let me find what is I cap dot I cap, I cap dot I cap. Same line. So their angle will be 0. So it's modulus I cap. Then again modulus I cap, and then cos of angle between I cap and I cap. Since they are same vector, so angle will be what? 0. So I cap is unit vector. So it's 1, magnitude is 1. This is also 1. Cos 0 is also what? 1. So I dot I, j dot j, or k dot k, they will be all equals to how much? 1. But if we take ij, so see, if this is x-axis and this is y-axis, in this x-axis we have I cap, along y-axis we have j cap. So what is the angle between I cap and j cap? Is again 90 degree. So if it is 90 degree, so cos 90 is how much? 0. So if you take different vector, ij, ji, ki, kj, so they will all become what? 0, because the angle is 90 degree and cos of 90 degree is how much? 0. Okay, now a bar dot a bar. So a bar dot a bar you can write like this also, modulus a bar whole square. So their value will be same, or you can simply write a bar square. Okay. In property number 7, you see m into a bar, then dot b bar. So m is a scalar quantity, means without any direction. So m we can take outside. So it will be m into a dot b. And then one of the most important formula, how to find the angle between two vectors. So you already know what is a bar dot b bar. It is modulus a bar, modulus b bar, and then what? Cos of theta. Right? So from here, what is cos theta? It will be a dot b divided by modulus a bar, then modulus b bar. Okay, so this formula. So by using this formula, we can find the angle between two vectors. Or if you want to write it more precisely, then you can write cos inverse of a dot b divided by modulus a bar, and then what? Modulus b bar. This is how you'll find the angle between two vectors. Then in scene property number 9, if a bar components are given a1 I cap, a2 j cap, a3 k cap, and b bar is also there. So if you want to find the a dot b, now see a dot b means first we'll find the dot product of all these three terms with a bar, a1 I cap. So a1 b1 I cap dot I cap. So just now we got no I cap dot I cap is how much? 1. So it will be a1 b1 this term. But when you take the dot product of these two terms, a1 I cap dot b1 j cap, so I cap dot j cap is 0, so it will not come. In the same way, a1 b2 in this case I cap dot j cap, so it will become 0. Similarly, a1 I cap b3 k cap, so I cap dot k cap is again 0, so it will not come. So only a1 b1, then a2 b2, and then what? a3 b3, this will come. Okay, so again this particular result you have to use in so many problems. Now let us do some applications. Like you see, a bar and b bar is given. So first you have to find their dot product and also angle between them. So a bar and b bar is given. So a bar dot b bar. So it will be 2 I cap plus 2 j cap minus k cap dot 6 I cap minus 3 j cap plus 2 k cap. So just now you find now what is a bar dot b bar. A bar dot b bar is a1 b1. So here a1 is how much? 2, and b1 is 6. So 2 into 6 is 12. Then 2 into minus 3 is minus 6. Then minus 1 into 2 is how much? Minus 2. It will be how much? 4. So it's so simple. After that, we have to find the angle between a bar and b bar. So before that, let us find a bar. So it will be root over a square plus b square plus c square. So how much it is? 4, 4, 1. So it will be 3. Then modulus b bar, root over 6 square minus 3 square plus 2 square. So it's 36. 36 plus 4, 40. 40 plus 9 is root over 49. Root over 49 is how much? 7. So what is the angle between them? So we have cos theta equals to, the formula is a bar dot b bar divided by modulus a bar, and then what? Modulus b bar. A bar dot b bar is our 4, and modulus a bar is 3. Modulus b bar is how much? 7. So it is 4 by 21. So this implies theta will be our cos inverse 4 by 21. Okay, it's very simple, right? So we practice some more problems of similar kind, so that you have a clear idea of this dot product and cross product. So let us take another problem. Here we have to show that for any vector r bar, this result is hold. So let us suppose that let r bar equals to r x I cap plus y j cap plus what? The z k cap. Okay. Then let us take the right hand side. So it is r bar dot I cap, then I cap, r bar dot j cap, then j cap, r bar dot k cap, then what? K cap. So you see, r bar means what? X I cap. I am doing only one. X I cap, other two are similar. X I cap, y j cap plus z k cap. Dot I cap, and then outside we have one I cap plus the remaining term, remaining two term. Now you see, this is what x I cap, and outside is also I cap. So I cap dot I cap is how much? 1. So we have only x. Then here j dot I will become 0, k dot I also become 0. So how much you will get? Only x. And outside there is how much? I cap. So x I cap. In the same way, from the next term you will get yj cap, and from the last term you will get zk cap. So this is nothing but what? R bar. So it's so simple, right? So that's why problems are very simple. Don't worry, just you have to practice it. Okay, now let us come to problem number 3. A bar is given, b bar is given, then we have to prove that a bar plus b bar and a bar minus b bar, they are perpendicular. So you remember that we have one property, right? When two vectors are perpendicular, if their dot product is 0. So before that, let us find a bar plus b bar, a bar plus b bar. So we simply have to add it. So here 1, then 1, 6 I cap minus 1 plus 3 plus 2 j cap, and then it is minus 3 minus 5, so minus 8 k cap. So this is our a bar plus b bar. Then find a bar minus b bar. 5 minus 1, 4 I cap, then minus, so it is minus 4 j cap, minus 3 minus plus, so it will be 2 k cap. Now let us find the dot product, a bar plus b bar dot a bar minus b bar. So dot product I will find 6 into 4, 24, then we will multiply this minus 8, and then we will multiply this minus 16, you see 0. Since their dot product is 0, so this implies a bar plus b bar is what? Perpendicular to a bar minus b bar, right? So this is also a very simple problem. So in most of the cases, you have to use that one. A dot b equals to a1 b1, a2 b2, and a3 b3. Now let us come to problem number 4. You see what is given here. Modulus a bar is given 3. Modulus b bar is also given, and dot product is given a dot b equal to 6. We have to find modulus a bar plus b bar and modulus a bar minus b bar. You just remember modulus a bar plus b bar, you cannot write mod a plus mod b. It will be different then. So what we'll do, we'll write like this: modulus a bar plus b bar whole square. I think you remember that there is one property like this: a dot a is equals to mod a whole square, right? So it will be similar kind. So what we can write? We can write a bar plus b bar dot a bar plus b bar, or you can simply square it: a square plus b square plus twice a b. That one also you can use. So first is what? A dot a. So a dot a is mod a whole square. Then next is a dot b plus, then it will be b dot a, and then b dot b is modulus b whole square. So it's a bar square. A dot b and b dot is same because dot product is commutative, so you can write 2 a bar dot b bar, and then finally mod b whole square. I'm showing that how it is coming, so you can write it directly like a square plus twice a b plus b square. Okay, so mod a, modulus a is 3, so it is 9, then 2 into a dot b is also given is 6, and then modulus b is 2, so b square is how much? 4. So it's 9 plus 12 plus 4. Okay, so how much it is? 25. So in the same way, a bar minus b bar whole square. Now you will write it directly: mod a whole square minus 2 into a dot b plus mod b whole square. So it will be 9, 2 into 6 plus how much? 4. So 13 minus 12, how much it is? 1. So I think you by this particular time you know that the problems are very easy. Okay, let us take one more. Here what is given? A bar plus b bar plus c bar is how much? 0 bar. Okay, a bar plus b bar plus c bar equals to 0 bar. Mod a is given, modulus b is given, modulus c is also given. We have to find the angle between a bar and b bar. Okay. So it's given that a bar plus b bar plus c bar is equals to 0 bar. This implies a bar plus b bar, we can write minus c bar. Okay, so if you take modulus on both sides, modulus a plus modulus b, it will be modulus of minus c. After that, what we'll do, we'll square it both sides. So just now we get it na. So it will be mod a whole square plus mod b whole square plus 2 into a dot b, and right side it will be simply mod c whole square, because minus it will become positive. So these values are given 9. This will be our 25. A dot b we don't know, so let us keep it like this, and then this is 49. So this implies 2 into a bar dot b bar is equal to how much? 34, right? 25 is 34. So 49 minus 34. So it will be by 15. This implies a bar dot b bar is equals to how much? It is our 15 by 2. So this is our a dot b. But what we have to find? We have to find the angle between a bar and b bar. So to find angle between a bar and b bar, what we will do? We know that cos theta equals to what? A bar dot b bar divided by modulus a bar, and then what? Modulus b bar. This is the formula. So a dot b just now we have, it is 15 by 2. Modulus a bar, it is already given in the question. Modulus a bar is 3, and the modulus b bar is how much? 5. So 15 cancel. How much you have? Half. So cos theta is half. This implies theta equals to how much? It will be your pi by 3. Now let us do problem number 6. Here what to show? That if a bar and b bar are two vectors, then we have to show that modulus of a bar plus b bar is less than equals to what? Modulus a bar and modulus b bar. So we have, see, we can write like this, no? Modulus a bar plus b bar whole square equals to how much? Modulus a bar square plus modulus b bar square plus 2 into a bar dot b bar. So this is equals to modulus a bar plus modulus b bar plus 2 into, what is the formula for a dot b? A bar dot b bar is what? A b, and then what? Cos theta. Or better you can write modulus a bar, modulus b bar, and then what? Cos theta. Okay, now cos theta. So that we have to find. We have cos theta is how much? Cos theta is less than equals to 1. Okay, the value of cos theta is either 1 or less than 1. So if you multiply both sides by 2 into mod a bar, mod b bar, then what you will get is less than equal to 2 into modulus a bar, and then what? Modulus b bar. Now you just compare these two terms and these two terms. So here, see what I am writing. Modulus a bar square plus modulus b bar square plus I am writing 2 into modulus a bar, modulus b bar. So I am not writing cos theta. So if we compare these two terms, like here, then which is bigger term? This is bigger term. When cos theta is absent, that is bigger term. So our symbol will be less than equal to. Okay, is it all right? Less than equal to. So this you have to write on the side note. So this implies, so finally what we will get? In the left hand side we have a bar plus b bar whole square less than equals to. On the right hand side now what you can write? You can write modulus a bar plus modulus b bar whole square. Okay, whole square. So if we remove the square, it's mod a plus mod b is less than equal to modulus a bar plus modulus b bar. So this particular inequality, since it is less than equal to, it is also called what? Triangle inequality. Okay, so let us do today's last problem. This particular problem is also called what? Cauchy-Schwarz inequality. So here what to show? For any two vectors a bar and b bar, we have to prove that a dot b whole square is less than equals to what? Mod a whole square and then mod b whole square. Okay, solution. So let theta be the angle between a bar and b bar. So you already know a bar dot b bar is how much? Modulus a bar, modulus b bar, and then what? Cos theta. Okay, cos theta. So what we have that cos theta is what? Less than equals to 1. Cos theta is less than equals to 1. So if cos theta is less than equal to 1, if we multiply both sides by mod a and mod b, so this will be less than equals to mod a, mod b. So we are multiplying both sides by modulus and modulus b. So this is nothing but a dot b. This is a dot b is less than equals to what? Mod a and then mod b. So now if you square both sides, a bar dot b bar whole square is less than equals to what? Modulus a bar square and then modulus b bar square. So this particular property is called what? Cauchy-Schwarz inequality. Okay. So here I did only 6 problems, but if I do some more problems, then video will be so long. But you just go and watch all the total lecture and practice all the sums, and from any book you at least do 20 to 25 sums. But if you struggle in doing some more problems, then you just tell me in the comment, then I'll solve some more problems for you. So I hope you like today's video. So kindly subscribe and share. Thank you for watching.